Okay, it's 4 o'clock and we can begin now. Good evening, everyone, and welcome to the 51st lecture in the Archaeological Sciences Center's webinar series. And thank you to all of you for joining this on a Saturday evening. And as you know, we have been conducting this webinar series for almost 3 years now, and this is the 51st one, and the last one for this year, 2024. And we will, of course, continue with it in the coming year as well, 2025. So please stay with us in the coming year as well for all the future lectures by different scholars. And today we have with us one of our very own, Dr. Ekta Gupta. She was actually a part of our Archaeological Sciences Center about 2 years ago when she came here at IIT Gandhinagar as an early career fellow. And she worked with us, collaborated with us, and especially under the mentorship of Professor Prabhakar, who is my colleague here at the center. And together they did some very wonderful work, which I think she will also probably be talking about today. So I will not reveal the secrets. And unfortunately today I do not have my colleagues with me, Professor Michelle Danino and Professor Prabhakar, since both of them are traveling and it's the end of the year. And I guess many of us are, already traveling or part of some kind of New Year celebration. So I will now, of course, request Purva to introduce Ekta to all of you, and I welcome Ekta once again to the webinar, and I hope she has a wonderful talk, and all of you. Oh, Michelle is here. He's here. Sorry, I didn't see you in the list, but good to see you here. And I hope that all of you enjoy the lecture and you will have some very interesting questions for Ekta, which we will take up at the end of the talk. I request all the participants to please keep themselves muted and to switch off their videos. And if they have any comments or questions or suggestions, please type them in the chat box and we will have a look at it at the end of the talk. So Purva, please, you can take over now.
Thank you, ma'am. Good afternoon, everyone. Welcome to the 51st lecture of ASC webinar series. It is my privilege to introduce Dr. Ekta Gupta, a Juan de la Cierva Fellow at Catalan Institute of Classical Archaeology in Spain. Previously, she was pursuing her postdoctoral research at IIT Gandhinagar, where she reconstructed past landscapes and addressed some long-standing archaeological questions related to the Harappan civilization. She got her doctoral degree from the National Institute of Advanced Studies, Bangalore. Her interdisciplinary approach integrates insights from historical geography, archaeology, geomorphology, remote sensing, and GIS to understand cultural and physical landscapes. Specialized in GIS and remote sensing based archaeology and geoarchaeology, she has been exploring hidden archaeological sites, ancient hydrological systems, and paleo landscapes through a blend of techniques. She has received a few prestigious awards and fellowships, including the current fellowship at ICAC Spain, the early career fellowship at IIT Gandhinagar in 2021, and Nehru Trust UK visiting fellowship. Beyond her research, she actively engaged in imparting training to students, research scholars, and professionals, as well as outreach programs. For today's talk, Dr. Ekta will deliver her talk on understanding ancient landscapes, the role of early maps and satellite remote sensing. Before we delve into the intriguing discussions, I extend my heartfelt gratitude to Dr. Ekta for taking out her valuable time to share her expertise with us. Ma'am, you may please begin with your presentation. Thank you.
Thank you so much, Purva. And it's my pleasure to be here. Thank you, IITGN, for inviting me to present on this topic. And it's my pleasure. And good afternoon, all of you, for joining this talk on Saturday. So I'll begin my presentation now. So in this talk, I'm going to cover briefly about historical cartography, satellite data, remote sensing data interpretation, and two case studies. One is on Tamrivarni Delta, and the second case study is on the work which I did at IITGN on Lothal and its surrounding area. So about cartographic data. So for India, we have historical maps from like as old as from classical eras, like maps by Ptolemies, Eratosthenes, and so these maps were basically a part of a world map they made at that time. And for the purpose of archaeology and landscape studies, they may not be that useful, but it was important to acknowledge their existence. So they are there, but they may not be that useful. So the focus of so the maps which we find useful for archaeological investigations, understanding past landscapes, are mostly from like our indigenous maps made in 17th, 18th, and 19th centuries, and then colonial maps which are they are from like available from 16th centuries onwards. And so there is this example of indigenous map. This is a map of Srinagar. And you can see like these are indigenous maps. They may not be cartometrically very accurate. The depiction is mostly, based on the importance of the site. The scale is determined by the importance of particular, element, objects on the area which is mapped. And they may not be, studied in a way we use, we georeference images and study them in GIS, but they can be studied through interpretation, by understanding relative positions of various objects with each other. And this is another example of this indigenous map of Jaipur. And you can see topographic details and information about some of the town plan, some buildings, water bodies, and so on. And there are other kinds of maps like road maps and maps of canals, which are also available. These are the traditional maps. And then we have colonial maps. And colonial maps, we also have variety of colonial maps. As I said, that they are available from 16th centuries onwards. So earlier maps are, mostly bird's eye view or like sketchy representation of a landscape, but they contain important details about architecture and various elements of the landscapes. Then we have detailed plans of different places which were of great importance to these colonial powers like French, Dutch, Danish, British. So these people were making these maps, these plans. Sometimes these plans could just be a blueprint of, a plan they thought of developing a city or a fort, and that never got executed. So when we study, we should also be careful about that, whether it's an actual plan or it's just, a blueprint of some plan. Then we have large scale maps, which, covers relatively smaller area, but in great detail. So you can see the detail in this map quite accurately depicted the shoreline, coastline of Mumbai, and this port area also is in quite great detail. And it also, apart from, the inland details, it also marks bathymetry and, areas that could be dangerous for a sailor to navigate to Bombay port. Then we also have these topo sheets. These are, made in early 19th centuries to, late 19th century, and then they were revised in 20th centuries also. And they contain tremendous details of the landscape. And here is one example how it shows this mound in this map. this mound is actually at that time Lothal site as well, like Harappan site was not discovered, and it was represented as just a mound in this site. So these maps actually, because they were made at a time when the land was not that disturbed, people usually used to avoid such areas where ruins were there, or any archaeological site or graves or temples. They used to leave it abandoned, like they don't disturb them. So these maps contain information about these sites also, apart from the topographical information. So information about water bodies, streams, canals, which may have altered or may not exist now, can be seen in these maps. So they are important source of information. So these are, we have plethora of maps now, because with digitization of these maps, a lot of scanned copies are available in many of these. On the right side, I have put names of different websites where we have, a lot of maps available. And on the left side, there are these archives where you can go and check these maps. Now, maps, they because they are abstract representation of reality, so they are prone to errors. And errors happens because of many reasons, because of the process of map production, choices of cartographer, and I will discuss that later, like the factors which cause errors in maps. But we also need to understand that map making as a process also involves several steps, and at each step errors get introduced. So these are different, the technology when these maps were made. So maps of older times are usually less accurate, but that doesn't mean that, it's a rule. So sometimes, older maps may represent things accurately and the later periods may not. So that depends, because the other thing, there are other factors that also, determine the accuracy of a map, such as purpose. So if a map is made for navigation, it may be more useful for or accurate from a sailor's perspective. And, if it is made for just for decoration purpose, so the information may not be given value. So, it may not have that accuracy. And then originality of the map. So again, it depends whether the copy we got through these archives is original or it's a copy of some original. So sometimes getting this information is difficult. And in that case, sometimes temporal context may get lost, and we may find it difficult to find what was the exact temporal context of the map. And then cartographic representation, misrepresentation, errors introduced in the process of cartography, biasness of cartographers, and so on. Then the scale. So smaller the scale, the chances of errors, generalization is more. So, and then as I said, that there is also a scale called scale of importance, and then that also can cause some kind of inaccuracies in maps. So this is one example of this map, which shows the river flowing just next to, like, abutting this fort. And current satellite image shows the river is, there's a gap or distance between the river and the fort, which may lead us think that the river might have changed its course. However, there is another map of the same time, and it shows how the river flows now. I mean, we don't see any difference. So finding the correct map is important, and that's why we need to look for more and more data. So now coming to the second part of the presentation, the satellite data. So I'm sure that you might have seen this kind of satellite images. Yeah, so you might have seen this kind of satellite images. Basically, how when we have also seen, I mean, this represents exactly a scene on the ground as we see from a flight, right? Exactly how we see on the ground surface. So the thing is so what satellite does, it captures data in different bands, and the software combines these images and makes composite images, such as the previous one, the true color composite images, where we see things as they are, in the true color combinations. However, the satellite data captures information beyond the visible, visual spectrum. So our eyes are sensitive to this visible wavelength, which is like from 0.4 to 0.7 micrometer. However, there are like the electromagnetic spectrum is wide, and it includes several ranges, including infrared, microwave, and these three are can be captured using satellite sensors. So satellite sensors are designed to capture data in these different spectrum. So to accommodate this extra, information in the form of extra bands, we make something called false color composites, and which depends, the combination of bands depends on how each objects interact with these different wavelengths. For example, that we see vegetation green because vegetation reflects more in green wavelength in visible spectrum. However, it reflects much more in near infrared, and that is why near infrared images or the bands is widely used to study vegetation. And the way each object behaves or interacts to these wavelengths is called spectral signature of that object. So vegetation has a certain spectral signature, dry soil may have a different spectral signature, water has different spectral signatures, and these unique properties are used in remote sensing data to identify different features, whether it could be soil, damp or wet soil with high moisture, that could represent some buried water bodies, buried ditch, or buried channels. So I mean, this is the principle behind using remote sensing data to identify these, features on the surface that may not be so visible when, we see on the ground with naked eyes. So satellite images, these captures reflectance, emittance from the surface, and in different wavelengths, different bands, and these different bands are combined and studied, analyzed using different band combinations, different image composition techniques to highlight certain features. So in this example, this is Saraswati value channel, and it was highlighted using false color composite image, and so therefore that it could be seen very clearly. However, if you see it in true color images, it may not be that visible. Now how combining maps and remote sensing data be useful? I can explain. I mean, it can be very clear from this example. So this is a scenario where a water body, it could be a channel or any kind of water body, which with time slowly silted and completely transformed into some other kind of land use, can be identified. Yeah, so for example, what we see, we don't see any water body now because it has been completely altered by new occupancy, new land use change, and we don't know if the why this pattern is there. However, if we find some cartographic data, older cartographic data, we might that shows some water body at the place where we see some patterns, and this kind of give the context to this pattern. So in satellite images, these shapes can be identified, and using different band combinations, these changes can be highlighted and can be identified much more clearly. So now coming to the case studies, the first case study is about Tamrabarni Delta and the Korkai port. It is in southeastern part of Tamil Nadu. So So Korkai Port is an ancient port, and Korkai was capital of Pandya dynasty before before the beginning of Common Era. It was an active port known for pearl trade, and currently it is 7 kilometers inland. And there are other sites like Palakayal, which is identified as Kayal, a port that existed in from 6th century AD to around 16th, which was active till 16th century CE. And so this Korkai was actually active till 5th century CE, and then became, declined and became defunct. And then this Kyle port emerged as a new port, and it remained, for active for next around, 800 to 1000 years. And then, in 16th century around, it also became defunct because of siltation. And then another port called Punakayal, Tutukuri, these were occupied. I mean, these became new port when Portuguese came around that time in this area. So this shows also how siltation happened, how the land use change, land formation, the evolution of this whole landscape happened, and how people responded to these changes by shifting the location of these ports. So now, to understand how these changes occurred, what happened and how the landscape was at that time, we found this map of 1822. Though it's a smaller scale map, and as I said, that smaller scale map may exaggerate some things, and may do, generalization is much more in these maps. So that is why these maps show the gap between these islands and mainland much more than it was actually. And how I came to know, I'll tell you later. But what this map did was that it actually brought an imagination of a bay-like feature in this area. So if you remember the previous satellite image, you don't see any bay-like features, not even lagoons, or just a deltic area. So this map brought this imagination, and then I found this another map which is much more accurate, and the details are better. It shows not a bay land, the bay-like feature, but lagoons and distributary of the deltas. And then I found this another map which shows, I will highlight the features. It shows these water bodies. So lagoons are much more clearly depicted. These channels are also less exaggerated. Like, here the width is much more than actual width. And it also says that these lagoons are choked because you see the channels are very narrow. So the interaction of seawater with these lagoons is very limited, which means that, they are on the verge to get silted, which actually happened in, later centuries. So this, like when we fit this map to the present day landscape, it fits here. And now because this map did not have well-defined features that could be identified and which can be used to georeference scientifically. What I did, I tried to understand, to trace these features, on the satellite image. Luckily, actually, the shape of the modern agriculture preserved the shape of this water body, because, these were occupied later, and because they are occupied later, and then they followed the shape of this water body. So we can see the difference between the agricultural fields outside this, the feature, the water body, the lagoon, the shape of the lagoon. And basically that this helped the shape, the preserved shape, which I call like field marks, helped in very accurate delineation of these lagoons on the present day satellite image. So, and the channels were also similarly identified. So based on these signatures, very accurate delineation of these lagoons and paleochannels was done. And in a map, which was, this 1919 map, we don't see these water features. I mean, these lagoons and channels, which means that they were silted because they were already on the verge of siltation. So they silted in next 100 years. And some remnants of these, this lagoon is still there in the form of a small wetland here near Palakayal. So this is a study done in 2006 using remote sensing data. And just from simple, understanding of a simple visual interpretation of satellite images, this embayment was identified by the author, and they found traces of paleochannels also based on the satellite image, and that too, because at that time limited data was available. So this was based on, not like how now we have multiple different types of satellite data. So detection of paleochannels is much more easier, and, more accurately we can delineate. But this was based on limited data. However, this integration of information from these maps suggests that, the embayment cannot be limited to this, but beyond these, lagoons. And yeah. So, in the next slide, I will say how the evolution of this whole landscape was understood. But before that, I would like to say mention here that Palakayal, Pala means old in Tamil, and Kayal means lagoon. So it actually, because currently, and also in this, through this explanation, if we go by this explanation, we don't see mention of any lagoon. But these maps, as they highlighted the presence of lagoon, it also explains the names of these places like Palakayal, Kayalpatnam, which is also close to this big lagoon. Now, so to understand how the landscape would have evolved, so this a very simple bathtub inundation was done using a digital elevation model. However, I would not say that it depicts the actual sea level scenario in the past, because there are multiple factors that affects sea level change and its interaction with the land. So I'm I'm putting this disclaimer that I don't mean to say that this is the actual sea level scenario at that time, and this 8 meter and the level actually suggests that sea level was that much higher or not. So this is just to show at this 8 meter inundation level how much area gets underwater, and it need not to represent the actual scenario in the past. But it does give some idea about the landscape, the changes that occurred. So this, as we know that during the mid-Holocene, there are many studies which suggest that mid-Holocene, there was this episode of transgression, worldwide transgression, and these coastal areas were submerged during that time. So probably this is it is possible that during that time this much area was underwater, and so this was kind of embayment in this region. And slowly because of sediments brought by the river started making bay head delta. And also it is possible because it was a transgression was followed by regression. So these kind of scenario, the formation of bay head delta and the formation of ridges, which we see in the next images, beach ridges and the progression of bay head delta. Because when we have bay, it also gets enclosed and it creates conditions to the formation of lagoons, because when these kind of ridges are formed, it gradually encloses this kind of basin, leads to the formation of lagoon. So during this scenario, it is possible the Korkai port was came into existence, and this kind of scenario, landscape, feature development of these features provided a sheltered space for the Korkai, to make a port here. And then gradually with siltation, this port became defunct in 5th century CE. And then the new port, Kayal port, came into existence. So it's not exactly telling the scenario, but steps that how this landscape would have formed in this region. And then finally, the lagoon silted and the current landscape we see. Now, coming to the second case study, Lothal and the Null Corridor. So, Lothal is a Harappan site, and Harappans they were spread all across in the Saraswati Valley and also in Gujarat. They were engaged in intercultural maritime activities with regions as far as Mesopotamia, Arabian Peninsula, and Persian Gulf. And they also had established a very robust inter-regional trade network between resource-rich site and production and distribution centers. And especially in Gujarat, if we see, there are many sites along the coastal areas which suggest their maritime activity and the dense network of maritime activities. And Lothal being on the southern side, as an important intermediary site which was connecting resource-rich areas, which was providing raw material like a gate to the other sites which were engaged in trade and production of different crafts. Lothal also it is situated very close to Gulf of Cumber, around now it is 30 kilometers inland from Gulf of Cumber. A river Sabarmati, which flows around 20 kilometers east of Lothal, and there is a river called Bhogavo, which flows around 6 kilometers west of Lothal, and it is also close to this Null Corridor, and which connects little run of Kutch with Gulf of Cumber. Now, Lothal, as I said, it was an important Harappan site, and by many scholars, it has been considered, it was suggested as an important port, Harappan port. Though there is no doubt based on the archaeological evidence, there is no doubt on Lothal's being a port, because it is known for this structure, basin structure, which has been identified as dock, a platform close to it, which is identified as var, and the presence of Persian Gulf type circular seals in Lothal, clay model of boats, and then the seals typical in the seals of statite from Bahrain found at Lothal. And so based on different I will discuss in later slides, so why Lothal was important and the issues and some debates that are around Lothal. So first is the dockyard theory. So whether the structure which is there in the Lothal, the basin structure, whether it was a dockyard or it was just a reservoir, or about the Null Corridor, whether it was directly connected to Little Run of Kutch. This Gulf of Cumber was directly connected to Little Run of Kutch through an extended arm of sea, or whether people were circumnavigating the Saurashtra Peninsula. So these were some of the questions. Now people have studied these questions and have come up with these evidence, especially by S.R. Rao, and then these were supported by Pindra, Shinde, Nigam, and other scholars. And so the structural evidence that are in support of dockyard theory is the presence of inlet, presence of wide mud brick platform, which is identified as wharf, vertical alignment of inner walls, spillways, and sluice gate. And then archaeological evidence like presence of post holes, presence of clay models and graffiti of boats in Lothal. Then medium-sized anchors, though it is still debated whether they were actually anchored of that time or not. Then evidence of intercultural, interregional trade, and this evidence provided by Dennis Frenes, that around 70 terracotta ceilings were present in warehouse. Out of all, like 93 found at the site had unique impression. So which suggests that the warehouse could be a warehouse, supporting status as a warehouse and its importance as a port town. And then geomorphological evidence like presence of estuarine shells in the basin, high salinity of soil in the basin, then the surrounding area, presence of low-lying passes that has been identified as paleo channel by S.R. Rao, and on-field identification of paleo channels on both sides of the settlements by S.R. Rao. Then there are later studies using multi-proxy analysis suggested presence of paleo channel. So this is the paleo channel identified by Khatkikar, and they also identified tidal inlet tidal deposit 100 meter north of Lothal. And then this study by Archana Das and others have identified presence of estuarine environment near Lothal during the Harappan period. So, and the sea level was also, the study suggests higher sea level during the Harappan period. Another important thing is that the tidal, this area has high tidal range up to 11 meter, which makes the inflow of water much more inland. And the mention of such higher tidal occurrence was also there in this 2,000-year-old textual record, Periplus Marissa Artheria. And also this area is tectonically active. So these are the complications about the study area. Now the criticism about dockyard theory. So first criticism, why Harappans require this sophisticated structures like that? And the second is there are no comparable structures like that in medieval and ancient India. And then the third one is like speculation about the right-angled passage of the canal. So what is the right-angled passage? I will discuss that here. So initially, Rao discussed about, so when they were digging the site, they were excavating the site, they first found the this inlet on the eastern side, and he suggested that there would be, the dockyard had access through an inlet on the east. And later he found evidence of a paleo channel on the west, and then he suggested that there could be the dockyard or the basin was connected to this western channel through a nalla or channel like this. And then later he found as the excavation progressed, he found another inlet on the northern side of the basin. And then he proposed this interpretation that in the first stage, when the channel was flowing on the west side, the access was through the northern inlet, but when the channel migrated on the eastern side, the access to the basin became from the eastern side. He also noted in his excavation reported incidents of floods, massive floods. In fact, the stages, the phases of the cultural deposits is actually different stages is determined by these flood episodes. So there are alternative views about the structures, whether, there are people who suggested it could be a water reservoir or it could be irrigation tank. However, it cannot be tank, as Paushal, Rao, Deloche, and Vindra has pointed out, that, because of these reasons, the city drain discharges into the dock, and the tank had marine organisms and gypsum crystal, which makes it unfit for any water tank purpose. And also there are seasonal inundations to raise crops, so it's not required to have a structure for the water reservoir. So then there are other important questions, like, was there any viable hinterland near Lothal? And about the feasibility of circumnavigating Saurashtra, because it involves higher cost of traveling to a longer distance, and also the risk because it's precarious. The Gulf of Khambat is not that easy to navigate. So did Harappans circumnavigate Saurashtra? It seems unlikely, because there is no Harappan sites between Lothal and another Harappan sites called Nageshwar, which is at the mouth of Gulf of Kutch. Now, then if this was not the route, whether Null Corridor was navigable or not. So as people suggested that this was an extended arm of sea during the Harappan period, it is possible they were navigating through it. But whether it was an arm of sea or not is a question. So this is, there are studies by different scholars using multi-proxy analysis of sediment. They dig from Null Sarovar, which is at the center of this corridor. And this study suggested that marine environment existed, but it was, much, much before the Harappan period. And during the Harappan period, this study does not show any marine evidence. And this Null Sarovar had lacustrine environment at that time. However, there are early modern records that mention about Saurashtra getting disconnected from the mainland seasonally, and which makes Saurashtra an island for 6 months. Now, what we did, we used remote sensing data, cartographic data, elevation models, and field observations to revisit this whole landscape. And so identification of paleo channel was done using remote sensing data. So we tried different methods to identify paleo channels. So one was, and the most useful was, this temporal PCA, principal component analysis of shortwave infrared bands of Landsat data. And it helped in identifying, you can see the paleo channels here quite clearly identified. And then this study also used methods, suggested by Orengo and Petri, using Google Earth Engine. And however, these methods were, not that helpful for this area, as this temporal PCA of SWIR was helpful. So finally, this image was used to delineate paleo channels. And around 55% of paleo channels was the total paleo channels identified through that method. Then the rest of the paleo channels were identified using microwave data. Different, like this is seasonal composite of Sentinel data, and then ALOS pulsar data. And then we used very high resolution images, because sometimes in this example, you can see this the channel is not that clearly visible in the temporal PCA of SWIR, but it is much more clearly visible in this satellite image, very high resolution satellite image. And also we use these images because they are kind of, snapshot or photographs of the very high resolution photographs of the ground. So these are used as a validation for the channels identified using other methods. Then analysis of coastal areas. So this is like simple bathtub simulation to understand what areas, if the sea level will rise, how much area will get submerged, and which makes, and I mean there are many studies already published, and this study also investigated this area much more in detail. And like these studies plus this study suggested that the run was navigable during the Harappan period. And then the focus was on the Gulf of Cumber and the area around Lothar. So paleo shoreline was delineated by combining different methods, but more importantly, by understanding the present day landscape. So this is the paleo creek. This is the present day creek, which is because, as I said, that this area has very high tidal range, and this whole area is very shallow. I mean, very gentle slope. And so the ingression of tides is quite inland. It goes up to 8 to 15 kilometers inland, and there are these tidal marshes around these creeks, which make this whole area not suitable for any kind of habitation even now. So similar kind of image can be seen in the scenario can be seen in this. This is the same area, like this is this area, and we see the paleo creeks, and this is dried paleo creek and the tidal flats in this area. Further, up to 25 kilometers inland, we find these. So this is kind of like inundation or a scenario in the past, how it could be in the past, which makes the area up to 25 to 30 kilometers inland not suitable for any kind of habitation. And we also see Harappan sites or sort of Harappan sites around this area avoided this whole area. So by combining all this data, the coastline was demarcated. Now, analysis of the null corridor. So null corridor, because it lies in the depression between Saurashtra and mainland. So the digital elevation model was quite useful in understanding the flow of water and the whole depression. Then these indices, this is modified normalized differential vegetation wetness index that helped in mapping the inundation, seasonal inundation, which happens even now. So you can see this whole area gets inundated during monsoon. Then by combining all the data, we found that this whole area is seasonally connected even now. So, and the Sanal Sarovar, which is around less than 2 feet or like around 3 feet shallow, people navigate in this Nal Sarovar, and even in the streams here, which means that to navigate you don't need very deep water bodies. Shallow water bodies, seasonal water bodies like this could be enough for navigation. And to zoom in, I am zooming in this area. So these are interconnected playas, which are the interdunal depressions. They get filled with water during monsoon, makes the whole area interconnected. Here is this Bamni River, which connects to Nal Sarovar. And so here you can see some photographs of these streams and playas and this Bamni River. So even now people, have boats and they use it for navigation. Then, in the lower reach, the southern part of Nal Sarovar, there is this Bhogavo River, which is connected to Gulf of Khambar. So these, the Gulf of Khambar and little run of Kutch was connected, and even now it is connected. And if we, calculate the speed based on Fuyama's, who mentioned about his speed and the time he took to, navigate to cross Nal Sarovar, and based on that, it is calculated that it will take around 12 hours to cross from Gulf of Khambar to little run of Kutch. So, which makes Lothal, this whole study. So, just to summarize the results of the study, this was the paleo channel identified by Khatkekar. And this study identified whole network of paleo channels using variety of remote sensing data, and which established a direct connection of these paleo channels with the river Sabarmati, one of the major rivers flowing in this region, which was earlier flowing parallel to Vatrak River, and gradually it migrated to east and then captured river Vatrak. And the study also delineated coastal areas, paleo coastline. And then another important observation was that this paleo channel, which flows along Lothal and another Harappan site called Koth, so which also makes Koth a possible hinterland during the Lothal port. And another thing is that the Lothal is 15 kilometers from this paleo coastline, which is 15 kilometers inland from now. And if you see the tidal influence of Sabarmati River, it is around 14 kilometers. So if we take this paleo coastline and the distance of Lothal from it, it is also around 15 kilometers. So which makes that, it makes Lothal a very suitable location to make use of tidal flow, for berthing of ships. So, yeah. And this is, these two things are very important. And just a minute. Now, this is the present day scenario, and this is the past. Now, with with this understanding of paleo Sabarmati, which was flowing along the Lothal and Koth, and the presence of this navigable route that connects Little Run of Kutch with Gulf of Khambar, and the connection of the location of Lothal at an ideal distance from paleo coastline makes Lothal a very suitable location to for maritime trade activities. And so, these are suggested maritime routes based on this reconstructed paleo landscape. I would also like to mention here that not only understanding the past landscape, remote sensing data was also helpful in corroborating some of the excavation finding, mutually validating both outcomes of remote sensing data and also the findings, archaeological findings. So, for example, here this trench 43 was identified as the excavator found a bank slope of a former river, and it also lies at the edge of the paleo channel identified using remote sensing data. Similarly, these SRG 34, 38, 39 by the excavator, by SR Rao, it was suggested that it was connecting another channel, in the later stage. And we also see that it is actually aligning perfectly with the paleo channel, because the paleo channels also suggest the narrative which SR Rao suggested, that the river from west migrated to east. So Yeah, so when these things actually, when we combine, integrate all the information obtained through various sources, various ways, it makes a very strong story, strong understanding of things. So with this, I will conclude this talk. So early maps are unique source of spatio-temporal information of past few centuries because they are available from 16th, 17th centuries onwards. And but it is important to understand that they can have some errors. They are limited in providing information, and the interpretation should be done very cautiously when we study these old maps. And if we integrate the remote sensing data with early maps, they offer interesting and innovative perspective to reconstruct, to understand past landscape. They also help mutually, validating findings or understanding from each other's, like from archaeological understanding, from excavations, from historical cartographic data, and also we also validate remote sensing, the interpretation of remote sensing data using the other kind of maps and archaeological data. But I would like to mention here and emphasize on this that remote sensing data or these maps offer visual insights into landscapes, but must be complemented by field and laboratory studies for deeper and more accurate understanding. These data sets doesn't stand alone. They has to be studied in collaboration with other data sets. Future prospects. So these kind of studies have immense potential for future investigations. If we talk about case studies per se, Tamribarni Delta has great scope to study further, to understand first of all what we have understood from this map and remote sensing based study needs to be validated from ground based investigation, laboratory data. So that needs to be done. Similarly, we need to do some archaeological prospection in these sites. Such studies requires upscaling across space and times because we have maps of various parts of India, lots of maps of different regions, and they needs to be studied. We need to study chronology of paleochannels. So this is a first step. When we use remote sensing data, it is kind of a first step to understand more. So it can provide you location where you can collect your data for chronological understanding, maybe to do archaeological prospections. So this is just a beginning, I would say. These are some of the papers. The things which I covered in the talks are discussed in this paper. These papers in detail, so can be referred. And I would like to thank all the supporting pillars from National Institute of Advanced Studies, where I did my PhD. The work on Tamribarni Delta was a part of my PhD, and the work on Lothal and Nal Sarovar, Null Corridor was a part of the work research I did in IIT Gandhinagar. And I thank all my mentors in NIAS and IIT Gandhinagar for their invaluable inputs and support, especially my PhD supervisor, Dr. M.B. Rajni, and my postdoc supervisor, Dr. V.N. Prabhakar, for their immense support and for sharing a lot of information and for their mentorship, supervision. I thank my present institute, ICAG, and Nehru Trust, officials of Nal Sarovar Bird Sanctuary, local community where I conducted my fieldwork, friends at NIAS, IITJN, and ICAG for their immense support. Thank you.
Thank you, Ekta, for this lovely talk. And it was very interesting how you integrated early maps with modern technologies. I now request the participants to type their questions or comments in the chat box, and we will take them up one by one. So I already see that there's one question from Payal Sen. She thanks you for this talk and asks, is it possible to identify and record the changes in landscape through time of a certain region by using remote sensing? What are the limitations?
Yeah, hi Payal. Thank you for asking this question. So, like as I think in the conclusion, I was trying to actually explain this that we can. So, for example, with remote sensing, I would say no unless we have some indicator. For example, you know. I mean, it's difficult because there are so many things. Like, for example, I'll give you one example of uh, Mahabalipuram. So in Dr. Rajni's, my supervisor's study, she studied this old map of Dutch old map from 17th century, where Mahabalipuram was marked on an island. Okay, so we know the time of the map, and it was an island. Now it is not an island; it's a part of the mainland. So from that we can understand with very surety that at that time it was an island. And so this kind of temporal understanding can be done, but again, like the surety, whether it was, we just have one data point for the time, and that may not be enough. With remote sensing data, we cannot say about the time. We need more. As I said, that we need to dig, to get core samples, to do some field investigation, get the sample and study them in the labs to understand the actual temporal context. But if we have old maps, we have them for like 400, 300 years old maps. So to some extent, they can provide some context, like in that example of the lagoon. So we know that lagoon existed in 19th century or maybe before that, but it did not. It silted in 100 years, and in 20th century, it silted completely. So this kind of understanding we can get, but not, with very surety, we cannot say. Yeah. And
okay, so the next question is by Rukia Nakash, who asks, can you kindly suggest a platform where we can learn more about remote sensing in terms of applying the technology?
So, to start with remote sensing data, I would say there are tutorials, free tutorials by QGIS. So, first, if you are very new to GIS and remote sensing, you can go through those tutorials. So, first, like just to understand the basics of GIS, and then there is this person called Ujjwal Gandhi, and he actually provided very good tutorials on remote sensing. So I think to begin, these could be good sites. And then I think IITG and NIAS, they also organize workshops. So you can also join these workshops. This could be a good starting point for you to get introduced to remote sensing in archaeology. So yeah.
Yes. This next question is by Narendra Tarsaria, who asks, is the ancient map and current satellite data difference? It shows the geography changes or the error in ancient maps?
Okay, Narendra, nice question actually. So, I have a paper which actually discuss about the challenges and errors in these maps and how to study them. So these maps, they do have errors, but as if you remember the Tambre-Barni Delta, this example, the case study. So where I found these maps, so first I checked the consistency. So if like several maps have the same information or not, that is one thing. The second is identifying features which we see in these maps on the satellite image. That's why it is so important to study maps with satellite data. So in case of the Tambre-Barni, this lagoon area, I first found in the map, and then I found the marks, the crop marks or the field marks, which are, matching the shape of the lagoon, which is marked in these maps. So overlaying of the maps, identifying the patterns on the maps, kind of corroborating the content of the map. So that is actually the most powerful thing which we can do with maps. So without remote sensing data, it was difficult to verify the content just based on, sometimes, for example, there is this map of Berlin, a cartographer Berlin, who made this mirror copy of Kollam, which is a place in fort in Dutch fort in Kerala, and he continuously, consistently published his copies of this map, which is a mirror copy of the not the how it looks, the fort looks, but how you see the fort in the mirror. So it was a error of production, engraving, and he continuously, consistently produced. So if we use lot of maps of Berlin produced at different times, it doesn't mean that, oh, we have 7 maps of Berlin and they are all same, it means they are correct. No. So we have to find more and more data, as much as maps we can find, to verify information from each other, and also to trace these changes, and also take help of remote sensing data to study. On top of that, we also should consider, because these maps were made during colonial time, we also find lots of textual records by travelers, and people who were surveying. So the textual records also very much required. And if we have, sometimes the relative positions, so we see a map has some feature, say some water body close to some monument, and then this relative positions can also be understand whether they have correctly located these features within the map or not. So if you see, like, if it has some 25 features, there are 25 features on the map, and if they are relatively correctly positioned, so the chances, you will trust the map more in that way. So you have to understand the content, and then use different maps and refer satellite images, and also refer textual records.
Okay, I see 2 more questions. One is by Saurabh Tripathi. He thanks you for this talk, and then he asks, can you discuss some important things or the basics if I want to learn or study a paleo channel of a river in a dense area?
Okay, so by dense area, you mean like urban area or like a dense forest area?
Probably, yeah.
Yeah,
Maybe it's not
okay.
very easily visible on the.
Okay.
Either on
So,
the
for example, if it is a urban area, so I assume the rivers are
He
much.
says urban. He has typed urban.
Okay. Thanks, Saurabh. So, urban areas, so I assume a river, a water body is usually bigger than any urban area. And urban area is like, and water channel, paleo channels are usually elongated in shape. So we can identify if we have to look a larger area. We may miss out finding exact, the channel on that urban area. But if urbanization happened much recently, so we have satellite images like corona images which were taken in 1960s. They could be helpful in identifying paleo channels in dense area. And also if the urbanization happened in last 2-3 decades, then there are Landsat data from 1980s and 1990s that could also be used to identify these paleo channels. So yeah, it is possible.
Okay, the last question. I see Michelle has turned on his video. Maybe he has something. But before that, we'll take this one. It's by Kavya Agrawal, who also thanks you for this wonderful presentation and asks, can we research ancient events, for instance, wars or migration through remote sensing?
Okay. Wars and migration. It depends what questions we are asking. If the study involves some kind of understanding of the landscape, explanation why people migrate from one region to another, then remote sensing can be used. For war, it can be used, but I think I would say it's mostly the GIS part. I mean, you need to have some data points, which will probably be from some textual records, or maybe like war. If we talk about war during colonial periods, so historical maps are a great source of information. And Dr. Rajni, she was studying Tipu's, this rocket, and how much, how far the range was of Tipu's rocket, and how, so this whole Anglo, this war which happened between Tipu Sultan and British. So, to some extent it is. So if you have data, you can. I mean, it depends on the questions you are asking, actually. So, yeah, I mean.
Yeah. Okay, I don't see any other question. Michelle, do you have something to say?
No, I do not have any questions. I just want to congratulate Ekta for a very fine presentation, which brings out the rich potential of the field. I think that the Lothal study has far more potential still. It's, as you said, it's only a beginning, and it can revolutionize the whole idea of trade in the Gujarat region and even beyond. And this discovery of the Sabarmati Parallel Channel in particular is very, very important, because what could it have been used for? That remains to be worked out. So your papers jointly with Professor Prabhakar, I think, are very important landmarks, and I hope you will be able to take it further from there. That's all I have to say. Thank you, Ekta.
Thank you so much, sir. Thank you.
Thank you, Dr. Ekta, for this wonderful presentation. I think it was a very nice way to wrap up this year, to have one of our own alumni present. And I think Prabhakar was also there for some time. I saw him join, but now I don't see him in the list. But anyway, thank you to all the participants for joining, and hope you stay with us in the next year too, when we continue with the series. And thank you, everyone. Have a great weekend and Happy New Year to all of you. And thank you, Ekta. Enjoy your
Thank you so much, ma'am, for having me.